Hassler here. Okay, so I just want to give you some direction on multiple set number 7. It's on implicit differentiation and related rates. And so I just wanted to review some of these ideas with you. So again, this is multiple choice, set number 7 review. And we're talking about implicit differentiation / related rates. Okay, so recall that implicit differentiation, I'm just going to abbreviate. Implicit differentiation means that I'm taking the derivative of a function with respect to x. Yeah, I know, we always do that, right? But the caveat here is where the variable that you're taking the derivative of is not x, okay? So I'm taking the derivative of a function or a variable with respect to x, but the variable is not x itself, okay? And so I'm actually going to run through an example here with you to remind you what this looks like. So let's say that my directions are to find dy dx, given that I have 2x plus y squared equals 9. And so I have to take the derivative with respect to x to each of these terms. And I notice that, I'm taking derivative with respect to x, and the variable I'm taking the derivative of is x, and the derivative of 2x is 2. But when I go to do this problem here, I'm taking the derivative of y squared. Well, y is not x. So I take the derivative of y squared, just like I would take the derivative of x squared, it'd be 2y. But I have to multiply by the derivative of that function with respect to x. And so I multiply by dy dx. I'm taking the derivative of y with respect to x, because that's what I was told to do. Okay, so I take the derivative of y squared being 2y times the derivative of y with respect to x. And then I take the derivative, 9 with respect to x. Well, the derivative of 9, that's a constant, so that's just 0. So the big deal here is that I need to multiply by the derivative of that variable. Now you could write dy dx when you do that multiplication. You could write y prime. Those two things are equivalent, okay? And then your job is to isolate the dy dx. Now, implicit differentiation like this will pop up in all sorts of places. So just a generic problem like this will pop up in the multiple choice. A related rate problem that could show up in multiple choice or free response, or in the differential equations unit that we did, chapter 9, we had to take the second derivative of a derivative, and that forced us to do implicit differentiation. Okay, so I'm going to go ahead and I'm going to isolate the dy dx. So I would subtract 2 on both sides. And then I would divide both sides by 2y. And so I would get negative 1 over y would be dy dx. Okay. Okay. Now let's just review what a related rate is. So a related rate is using implicit differentiation to determine the rate of change. Okay, so actually what I would like to do is I would like to talk through one of these problems with you. So you're just going to have to take a look at your document, as I don't have our document up here for us to peek at. So I'm going to take a look at problem number 4 on this multiple choice. It says functions w, x, and y are differentiable with respect to time and are related by the equation w equals x squared y. Okay, really what that means is that w of t is equal to x of t squared times y of t, but look how messy that is, okay? So they're telling you that these are functions, w, x, and y. These are all functions of time. Time, or t, is the independent variable, all right? If x is decreasing at a constant rate of 1 unit per minute, and that's a rate, so that means that dx dt, that's my rate, is decreasing, that's negative 1 unit per minute, and y is increasing at a constant rate of 4 units per minute. There's that rate word. So dy dt, right, a function with respect to time, is increasing at 4 units per minute. At what rate is w changing with respect to time? Okay, so that means that I'm trying to figure out what w dt is, knowing, they say, when x is equal to 6 and y is equal to 20. Okay, so that's the information that I have, and now I'm going to use that information. I'm trying to find dw dt. What that means is that I need to take the derivative of each of these functions. I'm going to group that together because, look, they're being multiplied. I'm going to take the derivative with respect to each to t of each of these functions. So the derivative of w with respect to t is dw dt. By the way, that's the same as saying w prime, so you can write it either way, okay? Now I have to take the derivative of x and y with respect to t, but this is a product, so I get to do the product rule. Fun. All right. So product rule says this, and I'm going to erase my little line here so I have room. Product rule says this. I'm going to take the derivative of the first function, that's 2x, times dx dt, right? X is not the independent variable, okay? Times the second function, plus, that's a times, not a minus, plus the derivative of the second function, well, the derivative of y is 1, times the derivative of y, which is dy dt, right? I'm taking the derivative with respect to t, times the first function x squared. And again, you could have written this as w prime equals 2x times x prime times y plus y prime times x squared. Those all mean the same thing. So whatever is easiest for you, you do you, okay? dx dt I wrote off to the side. That's the same as x prime. dy dt is y prime. dw dt is w prime, okay? So whatever works best for you. So I'm going to take my function, and now I'm going to fill in the information that I know. I don't know w prime. That's what I'm trying to find. They say when x is 6, the rate at which x is changing is a decreasing rate of 1. They say when y is 20. The rate at which y is changing is 4. It's increasing, so positive 4. They say when x is 6. Okay. So let's see. I've got, yikes, I have to do this without a calculator. Okay. Let's see. Let's do 2 times 20 is 40. 40 times 6 is what? 240? Negative 240. Because I have that negative 1. Okay. Holy Toledo. Okay. So now I got 4 times 36, right? Well, 6 times 4 is 24. 3 times 4 is, 12. So 144, I think. Yikes. And if I go ahead and subtract these, I'm not getting any of these answers, am I? All right, so I'm going to say I just got to subtract these. So I got to go 240 minus 144. All right. So 10 minus 4 is 6. Got to cross that out. Oh, I got to carry 13. That's 9. Got to cross that out. Okay, that gives me 0. Negative, really, because the bigger number was negative. So W prime equals negative 96. Please say that's an answer. It is. C. Whew. Love it when I'm right. Okay, so that should give you a little bit of review as to how these related rates are going to work with the implicit differentiation. As always, complete these problems and be ready to ask me questions.